Hi class. In terms of these guided notes, you only have to do the ones that I do. If there's extra problems, it's up to you if you want to do them, but you only really have to do the ones that I go through on the videos. So let's dive right in here. We have three terms we want to start with: a conditional equation, a contradiction, or an identity. So just because you see an expression with an equal sign in between, numbers and letters with an equal sign, it doesn't mean that they're all treated the same. Some equations, which the ones we're most used to, are called conditional equations. And that's true for only some values of x. And that's why we end up usually solving for x to find out what values makes that equation work. But there's some equations that turn out to be a contradiction, meaning that there's nothing you can put in for x or the variable that'll make it true. And finally, there are also some equations where no matter what you put in, it will work every time. It's true for all values. So the first thing we're gonna do is take these three equations below, and it's gonna be one of these three terms above. Let's find out how we're gonna do that. Well, first of all, we have x plus 1 equals x plus 4. You can subtract x on both sides, and you get 1 equals 4, which is obviously not true. So whenever you get an equation that makes no sense, like 1 equals 4, we call that a contradiction, and we're done with that one. There's nothing you can put in for x on both sides, of course, that would make that equation true. The next equation, solve it like you solve any other equation. Let's isolate the x's. So I think what I did here was I subtracted 3 from both sides. Then I divided both sides by 3. X equals -4. Yeah, that equation works for a specific number. X equals -4. So we call that a conditional, and that's our normal equation. This part C here, first of all, I want you guys to change your leading coefficient there to a 5. It's meant to be a 5, not a 3. Now we're going to go ahead and distribute, right? Remember how we distribute? Multiply the 5 through to both terms. Multiply the -7 to both terms. Yes, you bring in the -7 to both terms, and you should get what I have. Remember, you can always pause these videos to kind of go through slower if I'm going too fast. Then I just combine like terms, right? 15x minus 7x, I got 8x. -10 plus 28 is plus 18. And if you look, something unusual pops up here. We have the same expression on both sides. So no matter what you put in for x, you'll get like 5 equals 5, or 9 equals 9, or 10 equals 10. So right there, if you notice that, you can call that an identity equation. Same thing on both sides. Let's just solve a couple equations. This is a review of Algebra 2. This is where we start. So first of all, whenever you see fractions in these equations, it'd be nice to clear the fractions. We call it clearing the fractions. So it's nice they all have a denominator of 6. So it makes sense to multiply both sides. You always multiply, do the same to both sides of an equation. Multiply both sides by 6. It basically cancels out all these 6's down below. But don't forget, we have to distribute this 6 to all three terms here. So we still have to take 6 times 5 to get the 30 right there. And it cancels out the other 6's and solve x equals 5/4. Next equation, we don't have the same number on the bottom, but we can find a common denominator. And if you take 8 times 5, you get 40. That is the least common multiple of 8 and 5. So we're going to multiply both sides by 40. We have 40 over 5, of course, equals 8. So we're going to end up multiplying these two by 8. 40 over 8 is 5, so we're going to multiply the top by 5 and distribute. Remember, we're distributing through parentheses. And there you can work through. We don't get a nice answer. We get x is approximately 5.3. Not all answers are whole numbers. Let's quickly talk about absolute values. Absolute value can be summarized by this phrase, distance from 0. So what do I mean? Well, if you see the absolute value of x equals 4, and you're supposed to find what makes that true, we're really asking here, what values are exactly 4 units from 0? Absolute value is just how far is distance from 0. Because the absolute value of a number equals 4, we're looking for all the values that are 4 units from 0. And on the number line, you can see that if you can go 4 to the right, you can go 4 to the left. And the answer, we have 2 answers. The answers are going to be x equals plus and minus 4. Those are 4 units from 0. Now we get a little tougher in this type of equation, but it's still the same idea. Which values are 21 units from 0? But because the whole side is an absolute value, what we're going to do is write this and split it into 2 parts. We're going to solve it as if we're going negative 21 to the left, 21 from 0 to the left, or 2x minus 5, 21 units to the right, just like we did above. And now we solve these equations separately. We get 2x equals negative 16. X equals negative 8 is one answer, because we're adding 5 to both sides there. And we also get 2x equals 26. So x equals 13. We get 2 answers because of the nature of the absolute value. And let's do one final question here. Sometimes you don't have the entire side absolute valued, so you should do some algebra to get it so the entire side is an absolute value. Then you can split it apart like we've been doing. So first thing I'm going to do is add 9 to both sides. So that gives us negative 28. Then I'm going to divide both sides by the negative 4. Okay, so just basically, just divide both sides, the entire left and the entire right side, by negative 4. Those cancel out. We still have the absolute value of b minus 2 equals 7. Now we can do the little split trick because the entire side is an absolute value. So b minus 2 can equal negative 7, or b minus 2 can equal positive 7. So add 2 to both sides, b equals negative 5, or b equals 9. Good luck.